Assalamualaikum guys, hope you're all doing good. In the last few videos we looked at control flow statements and how to work with them, like if-else conditions and loops. For the next few videos we'll be going over data structures in Python, starting with lists as the focus of today's video. So let's briefly talk about a data structure. What is that? A basic definition that I can think of that best describes it is that it's a way of storing and managing data efficiently. You can think of it as a basket for adding or processing data. A simple example of a real-life data structure would be a basket of fruits. Say I wanted to add in my basket an apple, a banana, and a mango. Python would recognize this collection as a list of items. So lists are defined by squared brackets, and we just generated a simple one containing string values. Pretty straightforward. Printing out basket will show our list of fruits in the console. To confirm its data type by just using the type function here, we'll see in the console that it's of the list type. Sweet. So a list is one of the main data structures in Python, and the item inside it can be of any data type. So we can have numbers, 1, 2, or even boolean values like true, and printing this out shows the updated basket here. Cool. We can access items from our list, much like how we'd get characters or words from strings, by applying the slice notation at the end here. An index 0 will just fetch the first item apple from our list, as you'll find in the console here. Alright, so individual items or even a range of items can be fetched from lists with indices in square brackets at the end. So indices 0 to 3 here would just get the first 3 items, the fruits from our list. We can manipulate lists further with the slice notation. Say I want to reverse the order of items in our basket. I can do that by applying a step of -1 with the full range of items in the slice notation, and by printing this out, will give us a reversed order of items in the list here. Now besides slicing lists, there are methods for adding and removing items inside them. So to add an item at the end of the list here, we can use the built-in append method for lists. Maybe adding grapes in the basket. Running the program will show that we get grapes as a new item at the end here. Sweet. Even if I wanted to add a list inside my list, maybe a small one with just numbers, it will then get appended at the end as a single item. So you can see that we have sort of a nested list here, with the sublist containing 1 and 2 is a single item for our main list. Awesome. If you'd like to add an item to your list at a certain position or index, say after apple I want to add orange, I can simply use a list method called insert, which takes the first parameter as the list index you'd like to place in your item, and the second parameter as the new item. So what we're doing here is adding orange in the position where banana is supposed to be at list index 1. So banana and the following items will be pushed to their next positions, and the list will grow by 1 item. Maybe we can see the difference with 2 print statements here. By running this, you'll see our original list followed by the updated version below, which now shows orange as the second item. Awesome. Now let's say we wanted to remove items from lists. Let's just work with our updated basket here. So one easy way to remove an item is by using the list method remove, inside which you can specify the item to be removed. So I'm gonna remove apple from our list. When I run the program, you'll see that apple disappears from the basket, since the first item now is orange. Alright. A fancier way of removing items is by using the pop method, which takes in the list index of the item you want to remove, and literally pops this item out of your list as the item itself. So let's pop out banana from our basket, also showing the updated list to see what's going on. You'll see that banana gets printed out, given that it was at index 2 in the list, and the updated list does not contain banana anymore. Cool. We can also remove items with the slice notation, so if I wanted to just keep our fruit items, excluding numbers and the boolean here, I could simply specify a range of indices. So we'd like to keep items until the index of mango, which is 3. So this slice range here will fetch items from the start of the list up to but not including index 4. Printing this out will show our filtered list, now only containing fruits. Alright. One more simple way of removing items is by applying the delete keyword at the start of your list with the specified item. So if I want to delete mango from our updated list, then I'll just use its index of 3 here. Running the program shows our list below, which doesn't contain mango anymore. Awesome. To remove a chunk of items, we can simply specify a range of indices here, and the del keyword at the start will remove those items. In fact, we could delete our whole list if we wanted, so if I just print out our list after deleting it, Python will throw a name error in the console saying basket is not defined, since we deleted it just now, therefore printing out something non-existent within our script. Cool. I'll just remove this code here, so we can keep working with our list when the program reruns, and we'll continue working with just fruits in our basket. Alright. Now besides adding and removing list items, you can also replace an element with another one. For example, if I wanted to replace apple here with a new item, maybe some melon. To do that, I can simply assign apple's sliced index position to our new item melon. So when I print basket out, you'll see that we now have melon as the first item. So apple here has been replaced. Awesome. You could also remove a chunk of items. Say I'd like to replace the first 3 fruits, but with other types of foods. Maybe chicken, beef, and fish. So the indices of the first 3 items will now be taken by these new 3 items. By running the program, you'll see that apple, orange, and banana have now been replaced by our 3 meat items. Alrighty. You've probably noticed an interesting thing here, that I assigned a sliced chunk from our list to 3 items separated by commas. If I were to make this collection into a list and run the program, we'll get the same result. So by assigning multiple items to new items, wrapping them around brackets wouldn't matter, as they'd be unpacked and inserted inside your list by index order of the items to be replaced. Speaking of assignment, you can also slice out list items to variables. If I wanted to assign my fruit items to variables with their respective fruit names, I can do that by simply applying variables in one line here. So copy pasting the items and removing their string quotation marks. Now we can simply assign these variables to our list in one line, and what's going to happen is each variable will be assigned by the order of items in our list. So let's check out the variables apple, orange, and banana with the print statement. By running the program, you'll see that indeed we get each variable printing out their respective fruit, apple, orange, and banana. Quite awesome. Now for the last segment of this video, we'll be looking at how to merge lists. Let's work with our basket of fruits, just removing these lines of code here. So let's say you wanted to merge 2 lists. I'll make a second list here called cakes, which can contain different flavors like velvet, cheese, or even a fruit cake. Sweet. Literally. If I wanted to merge my basket and cake lists to one big list, one way would be to just apply concatenation as you would between strings. By using the plus operator between them and placing basket here first, concatenating it to cakes would merge the lists in a way that the cake items will be listed after fruits, just as the items appear here while concatenating. So let's assign our result to merged as the variable name here, and generating its print statement. By running the program, you'll find our merged list in the console here, with fruit items followed by cakes respectively. This list contains a lot of sugar, eh? Yeah. In a way, we've extended our fruits basket by concatenating cakes at the end of it. There's actually a method for lists called extend, which can do a similar thing. So this method only takes in iterables, lists being one example, and what it does is that it extends our target list with items from the list inside extend. So here I'm extending a basket with items from cakes. Running this will show the same result as we had by concatenating the lists. Awesome. The extend method kinda did something similar to the append method, but the important difference to keep in mind between them is that the append method adds anything at the end of your list but as a single item. As you can see below that the cakes list is now a sublist of our basket. And the extend method only takes iterables. So for example, we use the number as a parameter. Python will throw an error below saying integer object is not iterable. So lists are iterables. By using cakes here again, we give the output of our basket with the unpacked items of cakes listed at the end here. Alrighty, we can extend our list with other iterables like a range of numbers, which makes this method quite handy. Say we'd like to add numbers 5 to 100, we can then simply use a range iterable. from numbers 5 up to but not including 101. And when I run the program, you'll find numbers 5 to 100 attached at the end of our list in the console here. Pretty cool. And much like the range function, lists can be iterated over with loops. So an example can be for C in basket, print C, where fruit will get printed out per iteration from this for loop, as you can see here in the console. Sweet. Many programming tasks may involve processing through data, and our data can be iterables where we'd like to filter out and keep certain elements. So let's go with a case of collecting odd numbers from our merged list. Let's define an empty list for odd numbers before the loop, and I'll be using if-else conditions to filter out unwanted items from our list, like even numbers and the string values. So the main if statement will check if the element in our list is not of the string type, therefore skipping over the fruits and cake items. The next if condition inside it, with number modulus 2 not equals to 0, will see if our numbers are not multiples of 2, i.e. even numbers. Under this if block, I can use the append method for our empty odd list, which will collect an odd number per iteration in the loop. And to finally see our resulting list printed out to the console, you'll see that we've made a list of odd numbers from 5 to 99. Pretty awesome. So that's pretty much it on lists that I'm going to cover for today. There are many methods that can be applied on lists, and if you'd like to check them out, I've included a link in the description below, a W3 School site that shows all the methods applied for lists. Cool. In the next tutorial, I'll be going over the next two data structures, tuples and sets. I hope this video was helpful for you. If it was, give it a like or a subscribe, and stay tuned for the next videos. Thank you so much for watching. I hope you have a wonderful day. Take care. Assalamualaikum.